Good morning everyone. Today I am going to discuss about the valence section when we find out the moment of resistance. In previous class we discussed about the same problem, which is the design of a rectangular beam to resist a bending moment equal to 45 kN meter and using M15 mix and mild steel. Here we calculate the factor bending moment, which the value is 67.5 kN meter. In this class we discussed about the same problem which consists about the valence section condition. The moment of resistance, that is mu, we know that is equal to 0.36 FCK into B into XM whole into D minus 0.42 XM. Here grade of mild steel is provided, that is Fe250, and for Fe250 steel the XM value is 0.53 D, which is given in the IS 456 2000. We know also the Fe415 the XM value is 0.48 D, and here the moment of resistance on the basis of Fe250 we need to calculate. So the value of moment of resistance mu is equal to, in the compression zone we calculate the value of moment of resistance or ultimate moment of resistance we can say. So mu is equal to 0.36 FCK into B into XM, which is equal to 0.53 into D, and whole into 1 minus 0.42 into X into 0.53 into D. Here the value of FCK we put 20 and the value of Fy is 250. So the total value of moment of resistance is mu is equal to 2.22 BD square. Here the B and D both are unknown, and we need to calculate the B and D by using the B and D equations, or here we consider D by B is equal to 2, or D by small d by B is equal to 2, or B is equal to D by 2. So here we consider B is equal to D by 2 value. So mu is equal to 1.11 dq. Here we put B is equal to D by 2 value, and so mu value calculate by putting the value of D, that is equal to 67.5 into 10 to the power 6 Newton mm. Here D is equal to 394 mm and B is equal to 200 mm we put. Then we add up the value of capital D, which is overall depth is equal to 450 mm and breadth is 250 mm and effective depth is equal to 415 mm. And here we calculate the area of steel required, that is AST, or we can say AT. The area of steel required, that is the value is factor of bending moment by 0.87 Fy whole into D minus 0.42 XM as per IS 456 2000. We putting the formula. And here the factor of bending moment or moment of resistance, that is mu, is equal to 67.5 into 10 to the power 6. So here put the value, and by 0.87 into Fy value is 250 grade concrete we consider. So the Fy is 250 and value to 1 minus 0.42 into 0.53 into 415. So here the total value of ST we can calculate 962 mm square or 9.62 centimeter square we can say. And here the minimum area of steel that is required, that is denoted as A0, it is equal to 0.85 BD by Fy. So here 0.85 BD into Fy, B value is 250 and Fy is 415 we put. So 0.885 into 250 into Fy 415 by 250, it is equal to 353 mm square, which is less than equal to 962 mm square. So this here the 962 mm square is the value of ST, and which is the actual area of tensile reinforcement, and there is here the 353 value is the which is the value of the minimum value of area of tensile reinforcement. And in beam, the diameter of main reinforcement bar is usually selected between 12 mm and 25 mm. Normally we have to consider the minimum value first, then we assume the 12 to 16 mm and 20 mm, and not more than 20 mm we consider in the basis part. And here provide two number of 20 mm and one number 20 mm bar giving total area. So here the total area for 2 mm of two number of 20 mm dia bar is 6.28 and one number of 22 mm dia bar giving total area is 3.80. So the total area of the both bar is equal to 10.08 centimeter, which is less than which is greater than 9.62 centimeter square, which is the value of the actual area of reinforcement bar or actual area of tensile steel. Here the diagram we provided here. So one number 22 number dia bar and two numbers of 20 mm dia bar are provided here. Total number of 3 number of dia bar provided, and breadth is provided to 50 mm and effective depth is provided 415 and radius, which is cover, is provided 35 mm. Okay. So in the next class we discuss the remaining part, which is the doubly reinforced section. Thank you.